Hello students, welcome in this online video lecture. Today we are going to start our second semester. In this semester I am going to teach you paper 4th analytical chemistry. Course code is CH344. This overall course include 6 topics, and out of these 6 topics, today in this lecture we are going to start our first chapter, that is solvent extraction. Now see, first we see what is the content of this solvent extraction topic. That is principle of solvent extraction. We are going to discuss distribution coefficient, distribution ratio, relationship between distribution coefficient and distribution ratio, factors affecting solvent extraction, separation factor, batch extraction, countercurrent extraction, application of solvent extraction, and some of the numerical problems. In general, this is one of the physical method which is used for separation of various compounds and their purification. That means, as we know that most of the techniques are used for purification, like crystallization, sublimation, distillation, vaporization. In the same manner, this is one of the technique which is used for purification of organic as well as inorganic compound. Now first we see how it works. Let's see first slide. In solvent extraction process, those sophisticated simple apparatus which we are going to use is known as a separatory funnel. But you know that is separatory funnel, and this separatory funnel is shown in the slide, right, in the left of slide corner. This is a glass apparatus which is made up of from a rich quality transparent borosilicate glass having stoppered bottle, stopper, and for this purpose here we are using a separation of this mixture. Okay, now this solvent extraction process or solvent extraction technique is also known as liquid-liquid extraction and partitioning. Now first we see very simple example, that is, in this extraction process two immiscible liquids are mixed together, taken in a separatory funnel. These two immiscible liquids having no tendency to mix with each other, and they forms a separate layer. For example, in separatory funnel we are taking a liquids such as water as aqueous solvent system and benzene as a organic solvent system. लक्षात येते? In this solvent extraction steps we are using two different liquids as a solvent. But in the first condition, these both liquids must be immiscible. Is it right? These both liquid must be immiscible, and these two solvent systems as they are immiscible, uppermost layer, see the first slide, uppermost layer may be having a solvent with low density. Is it right? It is shown in the figure. That is low density liquids having uppermost layer in separatory funnel, and highly density, those liquid which is having higher density, it is always settled at the bottom of separatory funnel. Is it right? Is it clear? In solvent extraction, we are taking a two liquids having different densities as well as both are immiscible liquids, and they always form two different layers whenever they are taken in a separatory funnel. Is it right? So in solvent extraction process we are using two solvents having both are immiscible with each other. Both liquids are immiscible having difference in their density, and these liquid extraction solvents are used for separation of different types of solids. Now how it works? That is solvent extraction process, how it works. That is compounds which is to be separated, that is in solvent extraction process, those compound which is to be extracted, they are taken in contact with two immiscible liquids with their difference in their densities. जे मिक्सचर आपल्याला सेपरेट करायचं आहे, जो कंपाऊंड आपल्याला सेपरेट करायचा आहे, those compound we have to purify. This compound is taken in a separatory funnel which is in contact with both liquids. दोन्ही लिक्विडच्या कॉन्टॅक्ट मध्ये ते मिक्सचर किंवा तो कंपाऊंड ज्यावेळेस येईल, whenever the compounds come in contact with two liquids having immiscible with each other, then these compound or mixture is having tendency to transfer, to dissolve in two liquids in separate manner. The compound is having difference in solubility or distribution of this compound in the liquid is different, and hence each and every compound, individual compound, when comes in contact with two immiscible liquid, that is aqueous solvent system and organic solvent system, then this mixture is having tendency to dissolve, to become soluble in the two liquids in different manner. For example, suppose एक example आपण घेऊ. Suppose we have to purify benzoic acid from the mixture in presence of organic solvent system, that is chloroform, and aqueous solvent system, that is water. Water and chloroform both are immiscible in each other. Or suppose we taking benzene. Then what happens whenever this benzene from mixture comes in contact with water as well as benzene or chloroform, that is our organic solvent system, then benzoic acid is having tendency to distribute to soluble in water in proper extent and in ether or benzene in another. That means benzoic acid never be equally distributed in these two liquids which are immiscible. Can you understand? Again I will repeat. समजा बेन्झोइक ऍसिड आपल्याला प्युरिफाय करायचं आहे, सेपरेट करायचं आहे मिक्सचरमधून. We are taking two solvents in the separatory funnel, that is water as a aqueous solvent system and benzene as a organic solvent system. When these both solvent system taken in a separatory funnel, two layers are developed. That is uppermost layer is organic layer having lower density, lower layer is of water, and whenever benzoic acid is added, to this separatory phenyl containing two immiscible liquid, then benzoic acid is get distributed in these two liquids in different way separately. That is, some benzoic acid is dissolved in water and some of the benzoic acid is get dissolved in organic solvent system in benzoic acid. Means concentration of benzoic acid in water is different than concentration of benzoic acid in which is distributed in benzene is different, and this is one of the principle which is used in a solvent extraction process. Okay, then second thing, this is one of the quantitative method of separation of compounds. Means we can quantitatively separate a different types of compounds by using these two liquids according to their distribution, and hence in solvent extraction compounds are separated according to using two different solvents, that is organic solvent and aqueous solvent system, both are immiscible. Third thing, when extracting solvent is stirred with solution containing solute, then solute from original solvent get transferred into the extracting solvent. Now how it works we see. Suppose we are taking this mixture. Initially we are taking benzene. Some of the solute, that is compound which is to be separated, is get distributed in a benzene, and then we are going to add some of the another solvent which is immiscible and shake the separatory funnel rapidly, then leave it for some time, then some of the solute from extracting solvent which is taken initially get distributed into another solvent, original solvent, and extraction processes start. So whenever two layers are separated, then benzoic acid is get somewhat distributed in organic layer, and another way it is also distributed in aqueous form. Next one, that is compound with other separation method, it gives a better separation effect, chemical precipitation and higher degree of selectivity, faster mass transfer than the ion exchange method. Now, what is the benefit of this solvent extraction as compared to distillation? Solvent extraction requires low energy consumption. See the difference. If we have to purify any compound by distillation, we have to arrange the assembly, right? But in solvent extraction, very sophisticated small instrument, that is separatory funnel, is used. We are taking 10 ml of organic solvent, 30 ml of organic solvent, 30 ml of aqueous solvent, which are immiscible, that's why they are recovered, and then we are extracting that particular solute or compound, which is solid form or liquid form. It requires very low energy. That's why by as compared to other technique like distillation, precipitation, then other ion exchange techniques, this technique requires very low energy, very simple sophisticated apparatus, large production capacity, continuous process, large separation technique can be used rapidly, fast action takes place, and easy continuous operation case of automation, ease of automation. So these are the some benefits of this solvent extraction process. Is it right? So in this first lecture, short lecture, we have studied काय काय आपण स्टडी केला. The separatory funnel is one of the glass apparatus which is used for solvent extraction process. Second thing, in solvent extraction, this is one of the purification technique as well as separation technique. It is used by using two liquids which are compulsory immiscible. दोन्ही लिक्विड एकमेकांमध्ये कसे असले पाहिजे, immiscible असले पाहिजे. And third thing, this technique is according to distribution law. That is, any compound is having always different distribution in which organic solvent and aqueous solvent comes in contact, and each and every compound is having their tendency to distribute to dissolve in the liquid in different manner when these both liquids are comes in contact with each other. So, okay, so this is one of the break of this particular topic or video lecture. Okay, thank you.